Hello and welcome to the C programming lecture on variable scope. What is scope? Well, up until now, what we've been calling a block of code is actually referred to something called a scope. Now, a scope is often related to curly braces, so whenever we create certain blocks of code that have curly braces, within those curly braces, we're actually creating a scope. So it's actually possible inside of a scope to redefine a variable name inside the inner scope. That sounds a little confusing, but we'll see some examples of what I mean. So first, let's start off with something called global scope. Now, global scope is the ability to declare a variable outside of the scope of a function. So for instance, in this case, we are declaring a variable x at the outside of our main function, and we are using it inside of our main function. Now, this variable can be accessed through any other function or any other block of code that we create. So for instance, what we're doing, we're assigning the value 100, and we print out the x variable as our first line of code inside the main function. We then reassign the value 200 to x, and then we print that out. So you can see that we have the ability to read and write inside of this variable x that is declared at the global level of this file. Okay, so let's go ahead and talk about something called function scope. So just like I was saying before, a pair of curly braces creates something called a scope. So what we can do is we can create a function. So we have this function down here called test, and we can call that function, and we can have the same variables defined inside of it. So I know this may seem a little confusing, but if you take a look here, what we're doing is we are assigning a variable x to the value 300. We are printing it out. We are calling our function that we named test, and then we are assigning a variable inside of this function named x, and we are assigning the -1 value. We are printing that out. This function has ended because it hits the bottom curly brace. That's the end of this function. It jumps back up to this line of code, line 11, and then it prints out our original x value inside of this scope. So you can see that we can create different we can create variables with the same names inside of different functions. So function scope over global scope. Now, the last two slides kind of have some contradicting rules. So what if you had a globally scoped variable name with the same as a variable scoped inside of a function? So for instance, in our last example, we had the variable x scoped locally to the main function. What happens if we pulled that out and put it into the global space? So just take a moment and try to think about a way to write this program. Just like I said, you can possibly take the last example on the slides and just move that variable out and just see what is possible by printing out the values and the addresses of those variables. So it turns out that we can actually access both globally scoped and locally scoped variables. So we can see here that what we're doing at the top in line 3 is we are creating a x value or x variable, and this variable is assigned the value 100. We are printing that out, and then what we are doing is not redeclaring, we're like redefining a new x variable, and this is our locally scoped one. Right, and we can actually see this and which addresses these correlate to. We can see that this address at the top is much different than the one at the bottom, and that's because it's actually referencing a different one. And this is a very big point of confusion sometimes when reading code and using global variables. So typically you'll see a lot of other literature, like a lot of other people will tell you not to use globally scoped variables because of reasons like this. So again, we're creating scope with curly braces. So we actually don't even need to create a function or anything of that nature. We can just create some curly braces that really have nothing wrapped around it. Now, this also works for things like our selection statements and later on loop statements and all these other things. but we can simply just create a pair of curly braces and redefine some variable here and print it out, and you can see that the addresses are actually different as well, right? So if you compare what is going on here, we have the output 300 here, which is our inner scope, this little curly brace here, and then the first line actually references the top one, which we can see both on our first line of output and our second line of output, or our third line of output, I'm sorry. That is the same address. These two are referencing the same variable, whereas our middle one, like I said before, is actually referencing this block here. So go ahead and just doing a brief recap of variable scopes. Variables can be scoped either globally, locally. We can have an inner scope inside of a function if we wanted to, just by creating some curly braces. Just keep in mind anytime you see curly braces to remember that that variable could either be outside of that scope or potentially declared inside of it. Just, you know, pay attention, especially if you're working on larger projects that may use global variables. Just pay attention to what the context is of the variables and what is being manipulated. All right, so let's go ahead and just write some quick examples here of some variable scoping. So first thing I'm going to do, like I always do, is I'm going to go ahead and make our main.c file. I'm going to open up my main.c file, and I'm just going to create my hello world program, just like I always do, because this is just a habit that I have, just to make sure, again, that all the tooling is working. You never know when things can go haywire. So let's go ahead and compile this guy. Let's actually just throw in, just in case, hello world. Again, this is just a force of habit for myself, and I don't really see that it harms me. It's just a good point to know that all my tooling's working, especially if I'm switching boxes and stuff. So anyways, let's go ahead and just work on some variable scoping. So let's go ahead and make a x, we'll say x global, and let's just make x global equal to -1. And what we're going to do is we're going to print out x global. We'll print out the value, and then we'll say the address as well. I believe we are using the pointer and x global, and let's do address of x global. So let's just compile this guy and run him. And okay, great. So there's that. We actually need to add a new line here, and let's recompile and just run it real quick. Okay, great. So now what we're going to do is we're going to say int x main, and let's give it the value of, let's just say 10. Let's do 2. All right, and then what we'll do is we'll print this guy out, x main value address p/n. So none of this should look incredibly new to you, besides the fact that we're using global variables now. So I'm going to keep these two together. I'm going to recompile, run, and we can see this is kind of what we expect already. So that's good. Also, you can kind of see the offset in the address space, but we can go ahead and we'll talk about hex in a later lecture. But this is just this is the address of the variable x global, and this is the address of the variable x main. Remember, address being the slot in memory that this is in. Okay, so now let's do this. Let's say int x inner scope. Let's make this, let's say, we'll make this guy, let's just say 5. I'm just going to copy this. And what we can do is just say x inner scope, x inner scope, x inner scope, right? So this is a good starting point. Okay, cool. So let's go ahead and see if we have the ability to access this variable outside of this scope block. Now, before I run this, just ponder what do you think may happen here? Let's think about this for a second. We're creating a scope. This variable is scoped within this block. Do you think we'll be able to compile? No. And you can see here that on line 16 is our error. And that's because this is a undeclared variable within the scope. It is only within the scope is only passed to the most inner curly braces. So this is why this will not work. And that is why globals work. So for instance, I have the ability to actually access this main here. So I can print this, and I can actually print global here, right? Like this. Again, so you'll see again that these addresses still align. Now, the interesting thing I can do is I can redefine these. So let's flip this to let's just say -100, and int x global is equal to -300. And now we see that these variables, although they have the same names, do not reference the same variables. So this can become quite confusing. Yeah, so this is just food for thought. Just think about how this stuff works. You know, if I can't access this outside of it, but if I define, even if I define these, for instance, so this is a good point. I cannot do, I don't believe I'm going to be able to do this. All right, it's probably going to tell me redefine. Yes, so I can't do that. That actually gives me an error. But what I can do is I can redefine outside of the scope. So that's why I have the ability to do something like x global equals 100, for instance. So I can do this, and then let's just go ahead and remove that one. So yeah. So anything that is in the outer scope, I have the ability to redefine within here. Anything that has already been defined within the scope block, I cannot redefine, which is why if I try to create another variable called xmain, it will yell at me. So I hope this lecture was kind of informative about the variable scoping. This stuff can be a little weird, but don't be afraid to use globals. There's honestly nothing really wrong with them. It's just you have to be careful how you use them. And often you'll see that a lot of different programs actually use them. A lot of people will tell you they're bad. It's better just to formulate your own opinions on how to organize your code rather than listen to these particular rule sets that are arbitrary. So anyways, hopefully you enjoyed this. Mess around with this example, perhaps create a function and try passing in some variables to that function maybe and printing them out and see what you get.